Okay, we're back and we're going to tackle number 14. Double check your version of number 14 because part C was worded awkwardly in my original, but it's written now in a way that I had intended. So as we go through this, hopefully you'll recognize that the original version, if you happen to read it, didn't express exactly what we were shooting for. Okay, so in this problem, we're just given a position function, and we're essentially going to do some higher order derivatives. So this position function, s of t, that tells us where a particle is on the number line at any time. So it's a little bit of physics stuff going on. Don't overthink it too much. We're going to stick with the math part of this, which is just finding derivatives and plugging in numbers. So for letter A, when you're asked to find the velocity function, v of t, all you need to remember is that the velocity is the derivative of the position. So it's really just s prime of t. So for us, v of t, the derivative of s, is just going to be 4t. Let me make a t that doesn't look like a plus sign. How's that? That's not great, but we'll count it. 4t, and then the derivative minus 8, and then plus 0 for the 11. So when you are finding velocity, you're just doing a derivative of position. So don't overthink it. You don't have to be a physics wizard. You have to be a calculus wizard, right? So you're going to do the derivative there. Okay. For letter B, it says, hey, what is the value of the velocity at time t equals 4? So all we're going to do is plug 4 into our velocity function that we just found. Piece of cake. All right. So I'm going to do 4 times 4. I put the 4 where the t is. Minus 8, 16 minus 8 is 8. So my velocity is 8 there. And the question didn't give us any units. Typically this is meters per second, or feet per second. But I'm not going to label this because the question doesn't have labels. So 8 is our velocity. So that's the first derivative. Now letter C asks us sort of a physics question. And that is, when is our particle moving forward? In other words, when is s of t increasing? And the way we check that is we look for when the velocity is positive. So when your velocity is positive, that means you're moving forward. Or if you're on a number line, you're moving to the right. Okay, velocity is kind of like a vector. It has a magnitude, which is your speed, and it has a direction. Too much physics talk there. So what we're going to do is we're going to find out where the velocity equals 0 and then use that to help us figure out where it's positive. So the strategy is we're going to set v of t equal to 0 because we're trying to find out where the position's moving forward. So set v of t equal to 0. That'll help us make a sign diagram. For me, that means I have to solve 4t minus 8 equals 0. That means 4t equals 8, and then what? T equals 2. So my point where this particle stops is at time 2 seconds. It's moving, and then it has a 0 velocity at time t equals 2, so it stops. Everywhere else, this thing's moving. If it stopped anywhere else, we would have had another number here, but we only have one number. So what we do is we set up a sign diagram. If you want to find out where a function is increasing or decreasing, you set up a sign diagram on its derivative. So I'm doing the sign diagram on v of t. And my zeros, like this 2 here, are sort of the dividers of my intervals. And basically, I just need to find out what's happening with the velocity over here. And I'm going to pick an easy number like 1, because 1 is to the left of 2. And I'll figure out what that is. So I got to figure out that answer. And I got to figure out what the velocity is doing over here, something like 3. And I'll see what that's doing. We're going to test those out, and that'll tell us where we're increasing or decreasing. Okay, so let's plug 1 into the velocity. That is 4 minus 8. That's negative 4. So my velocity is negative over here. What that means is the original function is decreasing on that side. Okay, oops, jeepers. I just bumped my screen there. And then v of 3, that would be 12 minus 8. That's 4. So that means my velocity is positive over here. That means my original function is increasing over here. So the interval that we're interested in is this interval right here. It says find the interval or intervals where the particle is moving forward. Our velocity is positive when we're greater than 2. So my interval moving forward on 2 comma infinity, right? That's how we use the interval notation there. So the interval is 2 to infinity. We found it by making a sign diagram. This is the interval where the particle's moving forward. If you want to think of that in math terms, our original function is increasing there, right? S of t is increasing. I'm going to write that underneath here. You'd think I've done this enough that I would do it right, but I can't. Not today, anyway. S of t is increasing. That's one way to say this. You could say v of t is positive too. So that's what's happening on that interval. Our original function is increasing because we did a sign diagram on the derivative. And in terms of physics, we call that moving forward. Okay, enough physics talk. What are the last things we have to do in this question? I have to find the acceleration, and I have to find out what it is at t equals 4. Okay, so back to some standard calculus. For letter D here, the acceleration, a of t, is just the derivative of velocity, which is just the second derivative of the position. So we're just doing those higher order derivatives. So I just need to find the derivative of my velocity function. Velocity function was 4t minus 8. So a of t, which is the derivative, is just going to be 4, right? So there's my derivative. And then letter E, is that what letter that is? My memory's bad this morning too. Letter E is just asking what is A of 4? Well, don't freak out here. There's nowhere to plug the 4 in. The acceleration is always 4, so the answer here is 4 as well. Okay, a constant function just has a constant for the value. Okay, let me zoom out a little so we can kind of see the big picture for this. We had to find the velocity function, which is the derivative of position. So that was our first derivative. We plugged in 4 to find out how fast this thing was going at 4 seconds, which was 8. 8, you can think of it as meters per second if you want. For letter C, we want to find out where the particle's moving forward. That's just physics talk for find out where the original function is increasing. To do that, we use the derivative, which is the velocity, to break this interval up into its places where it's positive and negative. We call that a sign diagram. I found out that my velocity is positive between 2 and infinity, so I know that I'm moving forward after 2 seconds. My interval is 2 to infinity. In common language, you can think of that as S of t is increasing on that interval, or the velocity is positive on that interval. In letter D, we had to find the acceleration function, which is just the second derivative. So that was 4. And when you plug 4 into that function, you still get 4. So that's it for that one. Okay. Thank you for listening. It wasn't the most awesome video I've ever made, but I think we got the job done. And of course, if this prompts you to have questions, then please just reach out so we can get these answered before you actually tackle the exam. In the meantime, take care.